Welcome to a lesson with Dr. Powell. Let's take a look at finding the area under a curve. Um, let's just do y equals 4 minus x squared. So this looks something like this. And let's go down here and let's find the area, but let's do it between 1 and 2. Okay. So to find this is like taking any area function at all. Perhaps even we could take the area function that starts at 1, using the notation we had before, and simply plugging in 2 for x. So 1 to 2, 4 minus x squared. Well, actually, and we could use x squared and dx if we're plugging things in here for x and we don't really care about the difference between two different variables, especially if we're not putting a variable inside the bounds. Then it's actually perfectly valid and fine to just keep this as an x. We could do dt, and that would be fine as well. But again, just convention, we don't always need to bother with that idea if these guys don't have variables in them, especially if we're just plugging a value into the area function in particular, just remembering that this area function is the one that starts at 1 and goes out. So this right here is called a definite integral over the x interval from 1 to 2. Okay, and we compute it in the following way. And notice we get a number out of this. It's not a function. It's because it's actually a specific number plugged into a specific antiderivative. And so we end up getting just a number. So, and oftentimes definite integrals, this form right here is usually deserves the name, or the name of definite integral is referred to when we're actually plugging in a specific value here. So when we plug in a specific value here, we end up just getting a number out of it. So it's kind of like an operator. We put in a function and then out comes a number. And that number is an area, very specific area on this x interval between 1 to 2, between the x-axis and the curve. So in this computation, what we do is we simply just take an antiderivative, doesn't matter which one, so we don't have to worry about a plus c even. We'd get 4x minus x cubed over 3. That's the antiderivative. Next, we plug in 1 and we plug in 2 and take the difference. So we end up getting 4 times 2 minus 2 cubed over 3, subtract, and then we plug in 1 in here. So we get 4 times 1 minus 1 cubed over 3. And the result is we get, let's see, so this is 8 minus 8 thirds. So it's like you're taking 2/3 of 8 right there. So 16 thirds, if you will. And then over here, this is, let's see, this is, we're subtracting off 4 minus a third, which is the same as 11 thirds. 11 thirds, okay. So making the subtraction, we end up getting 5 thirds out of this. So that means the area under this curve right here is 5 thirds. Thanks for watching.